Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
The next speaker is Rick Rashid. Dr. Rick Rashid is the worldwide head of all our research labs. He's the founder of Microsoft Research, and he founded it in 1991. And prior to that, he was a professor at Carnegie Mellon University. And his area of interest, research interest, is in artificial intelligence, operating systems, networking, and multiprocessors. He got his PhD from University of Rochester, and he has interest in Star Trek. So anybody has any questions on Star Trek, you can actually write it down for the session later, and you can ask him to answer those. I request Dr. Rick Rashid to come and deliver his talk.
So I love videos like that because it's just a great way of showing off just a tiny fraction of the things that are going on within Microsoft Research. It's funny, as Vidya was saying just a minute ago, I came to Microsoft in 1991 to start Microsoft Research. Before that, I'd been a professor at Carnegie Mellon University. And when you have the opportunity to start something from ground zero, start a new research lab, and then grow it the way Microsoft Research has grown, it's really quite a privilege, and it's a lot of fun for me to come to work every day and see the efforts of all the researchers that we have. But the honest truth is, when I started Microsoft Research in 1991 and I was employee number 1, I never imagined speaking in front of an audience this large about the research that my group was going to be doing. This is, in fact, the largest audience we've ever had for Tech Vista in India, and it's really, really exciting to be here. Now, when I came to Microsoft Research, I had a vision of what I wanted to do, what I wanted to accomplish. And this slide embodies that vision. It's the mission statement for Microsoft Research, and we have the privilege of having had the exact same mission statement now for more than 21 years. And certainly in the corporate world, that's very unusual. And in fact, it's actually unusual for someone to have my job for as long as I've had. So, being at Microsoft and running Microsoft Research for such a long time, I'm the Microsoft executive that's been doing the same job for the longest time. And it's allowed me to be able to have the level of consistency that we've had within Microsoft Research. Now, when I came to Microsoft, I had 3 things in my mind. First and foremost, our number 1 mission goal has always been to move forward the state-of-the-art in the areas that we do research. Our goal is to be at the forefront of whatever we're trying to do. Now, what's interesting about that goal is that nothing about that first part of the mission statement of expanding this state-of-the-art, nothing about that has anything to do with Microsoft. Doesn't say Microsoft on there at all. What it says is that if we enter a research area, if we're doing work in a research area, we want to push the state-of-the-art. We want to be the best that we can possibly be and the best in the world. And the reason that we have that goal is because if we don't do that, ultimately we're really not of much value to a company like Microsoft. We need to be creating new technologies and moving forward that state-of-the-art. Now, when we have great ideas, when things work, then the second part of our mission statement comes up. And that is we work really hard to get our ideas into use, into practice, which at Microsoft means getting it into our products so that literally 1 billion people around the world can use them. So that's the second part. Ultimately, both of those lead to the third part of our mission statement, which is really about the future. It's about making sure that Microsoft has a future, that our products have a future, and really that the field of computer science has a future. And while you may say to yourself, gosh, Microsoft's such a big company, of course it's going to have a future. Almost none of the companies that were Microsoft's competitors in 1991, when I first joined Microsoft, almost none of those companies are still around. The world of technology is constantly changing. We need to constantly innovate. We need to adapt. And if we don't do that, we'll disappear. And if the field of computer science doesn't keep doing that, and if we as a field don't keep creating new things and creating new value and changing the world, then the field will, if not disappear, it'll certainly stagnate and become much less relevant. So that's really, those three things say a lot about what we've been trying to do for the last 21 years. Now, a similar slide, Anandan put a similar slide up to talk about how Microsoft research has grown. Today, we have over 850 PhD researchers in our research labs worldwide. To put that in some perspective, that's more PhDs than Brown University has. We have more members of the National Academy of Engineering and Science and the American Academy of Arts and Sciences than most universities do in the United States. We publish more basic research in computer science than any other organization in the world. So we are the #1 creator of basic research in the entire field of computer science. So in this 21 years, a lot has happened, and there's been a lot of growth. Now, one of the things that I'm often asked is why? So why did Microsoft decide 21 years ago to invest in basic research when frankly most companies chose not to? Very few companies these days make the kind of investment in basic research that Microsoft does. So why does Microsoft do it? Why do we spend so much money? Why is it the case that 1% of our entire workforce is basic researchers doing fundamental computer science research? Well, there are a lot of reasons you can give. I've got some reasons that are up here. I mean, these are often the things that people talk about when they say basic research. One of the things that people will often say is, oh, you do basic research so that you can create new technologies, intellectual property. You're a source of intellectual property. And certainly, a well-run fundamental basic research group does exactly that. We do create new technologies. You've seen some of the videos already. I'll talk a little bit more about some of the things we're doing in a minute. But we absolutely do that. But I would argue that the reason you invest in basic research is not that. If you do great basic research, you will get new technologies as a byproduct of doing your work. But that's not the reason to do it. You could say, oh, I know. You invest in basic research so that you can do problem solving. You have all these really smart people, you give them problems and they'll solve them for you. Well, there's certainly truth to that. I mean, we do solve problems. I love solving problems. When you come to me, when a product group comes to me and they have an interesting problem to solve, that's really exciting. I mean, our researchers are trained to solve problems, we're really good at it, and they love doing it. But again, I think that's a byproduct of having a great research group. It's not the reason that you start a research organization. It's a value you get back from having it. Another thing people say is, oh, you're an early warning system. And we're certainly an early warning system. I mean, we often see the technologies in our research labs and in the research labs of our colleagues that will be the technologies of the future. And it's important for us to give that information to our product group colleagues. But again, these are all byproducts of doing a basic research lab. They're not really the fundamental reason you do it. The reason I think that you invest in basic research, whether you're a country or a company or a society, is this. It's agility. It's survival. Vannevar Bush, who's one of the key leaders in the United States after World War II that helped to create the National Science Foundation, he wrote a great paper on this, and he talked about why it was important for the United States after World War II to invest in basic research. And what he said was that, you know, America, the world, had just come through a great war. And scientists and engineers, researchers, had created the technologies that had a huge impact in winning that war. And he looked and he said, we need to make the investments in the future so that if there's another war, or if there's a disease, or if there is a famine, that we will have the treasure chest of ideas, technologies, and most importantly, people that will let us as a society adapt and change and survive. And I think that's why you invest in basic research. It's for survival. A company like Microsoft invests because, let's say there's a new competitor or a new technology or a change in the business climate. We as a company need to be able to rapidly change. And Microsoft Research creates for Microsoft that treasure chest of ideas and technologies and people that can lead Microsoft through change. So I think that's why you make those kinds of investments. And again, as I said, almost none of the companies that were Microsoft's competitors in 1991 exist today. Those companies did not invest in basic research. Microsoft did, and we're still here. Let me give you a historical example that can sort of convey the sense of how a research idea can change a company and can change the company's future. And I'll take an example from Microsoft Research in the very early days. So in the very early days of Microsoft Research, you know, one of our researchers, actually a small group, came up with this idea to reduce the working set size of 32-bit programs. So a working set is basically the amount of memory a program takes when it runs. And our researchers came up with really a lot of mathematics that proved that you could reduce the amount of memory a program took by about a factor of 2. Now we went to our product groups, and we were really proud of ourselves, you know, and we went to our product groups and we said, this is a really great idea, this is a great technology, you know, and we explained it to them. And just about every meeting we had, I was at all those meetings back in those days, just about every meeting we had, those product people looked at us and they said at the end of the meeting, you guys are really smart. I mean, we don't even understand all that math, right? You guys are just really smart. But we don't actually have this problem. You know, first off, it's 1992. We only have 16-bit programs, right? This was back in the old days. And we know we're going to have 32-bit programs someday, but we figure the memory sizes are going to be growing really fast, and we'll be able to use that up. Well, the problem was that because of some, political, economic, trade issues back in those days, that period from about 1993 to 1995, memory sizes for computers did not increase. And what happened was then Microsoft in 1995 was bringing out its 32-bit operating system, which was Windows 95, and its 32-bit versions of Office, which is Office 95. And unfortunately, they took up twice as much space because they were 32-bit instead of 16, but the memory sizes of the computers hadn't changed. And so that was a serious problem for the company. Well, luckily, we in research had this technology. We were able to allow the company to simultaneously ship those products. And our competitors didn't have the technology. So Lotus and WordPerfect, the competitors Microsoft had at the time, they weren't able to ship their 32-bit products in the same time frame. There's a huge economic value to Microsoft. I mean, we made, a few $100 million more that year, and we were a small company, so that was a lot of money for us. But more importantly, it gave us a huge competitive advantage during a period in which the world was changing. You were switching from one kind of computing to another. So that's the kind of thing that a research group can do. A technology that our product groups didn't even want us working on became important to the survival of the company and its long-term future. And things like that happen all the time within Microsoft. We're always confronting new challenges, and we're always inventing new technologies. Today, if you look at Microsoft's products, almost every product has technology for Microsoft Research or was built with technology for Microsoft Research. And I'm going to specifically talk about a new technology that I think is really exciting, just to give you an example of the things that we do. There's a technology in Microsoft Office 2013, the most recent release of Microsoft Office, just coming out right now, called FlashFill. And the technology is it's sort of like magic. You have a column in Excel, and you have another column, and you let's say you make some changes or some transformations. You give it a few examples, and it'll figure out the rest of those examples for you and fill in the rest of those columns in a way that's very magical. And you'll see that in just a minute. That technology, which is coming out right now, is actually based on fundamental research in automatic program generation. So the ability of computers to automatically write software. That's always been a dream in the field of computer science. We're now able to do it for small programs, but nevertheless programs that are of real value. And we're using that technology in FlashFill. I'm going to run a video so you can see more about it.
I'm Sumit Kulwani from Microsoft Research Redmond. I'm going to tell you about a new feature in Excel 2013 called FlashFill, which had its origins in Microsoft Research. Suppose you have a collection of social security numbers that you see in the first column, and you want to format them by inserting hyphens as you see in the second column. If you have hundreds and thousands of these rows, then doing it manually would be very cumbersome. A more principled way to do this would be to write an Excel macro. But if you are a non-programmer, like most Excel users, then you would be stuck. But now you can use the FlashFill feature to automate this task by just the press of Ctrl-E, which is a shortcut for FlashFill. The FlashFill feature builds over our program synthesis technology that can generalize examples into programs. So this is the opposite of program verification methodology that is used to generate test cases from programs to expose bugs in those programs. And this has seen decades of research. But now program synthesis does the reverse. It takes test cases or examples and generates programs that are consistent with those examples. In fact, we generate a huge number of such programs, but we have efficient data structures and algorithms to compute and represent such programs. Then we use the machine learning technology to rank these programs. We take the highest ranked program and run it on all the rows in the spreadsheet to give the user the output that they desire. Now, in general, it might not be possible to learn the user's intent from just one example, as would be shown by the second scenario, where I have a bunch of medical billing codes, some of which are missing a right bracket at the end, while some of which have a right bracket. Suppose my goal is to clean this data by adding a right bracket wherever it is missing. So if I give one example, then FlashFill generalizes it into a simplest program, which is to add a right bracket everywhere. Maybe this is what the user wanted. But otherwise, the user would observe that row 6 to row 10 are all incorrect, and the user can fix any one of these rows. So the moment I fix row 6, then FlashFill is able to fix other similar rows accordingly. FlashFill can also be used to perform complicated extraction tasks. So consider this worksheet that has a lot of customer data in the first column. So suppose my goal is to extract the constituent elements. All that I have to do is to give an example in each column and hit Control E. FlashFill can also synthesize programs that have limited form of conditionals and loops, as is illustrated by this scenario where I want to generate an abbreviation. If you want to learn more about this technology, then you can look at our CSCM Research Highlights paper. You can also use this feature yourself in Excel 2013.
So FlashFill is really a great example of how very fundamental work in core computer science research is able to create, in this case, a wonderful new feature in one of our products that's like magic, that people are very, very excited about when they use it. Now, the field of computer science is changing faster now than certainly at any time in my career. And I've been around a long time. So this should be exciting for you because so much is happening. I mean, one of the things that's going on now, one of the changes in computer science is referred to by the term big data. It's the fact that now we have the ability to process really astronomical amounts of information. We have enormous data centers. Microsoft has incredibly large data centers, hundreds of thousands of machines. We can process petabytes of information and do analysis and learn from that information. So this is what's called big data. Suddenly we're able to collect data about the world, about ourselves, scientific data, and process it in ways that we were never able to do before. I'm going to show you a project at our research group in Cambridge, England, called FetchClimate, that really leverages this idea of big data. What FetchClimate does is it collects environmental data from many different separate data sources around the world, brings it into the cloud, brings it into our Windows Azure environment, and then makes it available for scientists and ordinary people to get access to and to analyze. Let me show you the video.
Hi, I'm Drew Purvis. I'm a researcher at Microsoft Research Cambridge, where I'm in the Computational Ecology and Environmental Science group. The mission of that group is to carry out computational science that should let humanity manage our natural resources better. As part of that research mission, we develop new software tools, predictive models in geographical information services that should allow people to carry out that kind of cutting-edge research more widely. Today I'd like to show you FetchClimate, which is an easy, fast way for anyone to extract complex information about the climate, either just with a few lines of code in a program or even just through a browser. So here's our browser running FetchClimate. I'm in Redmond at Microsoft headquarters. So I'm going to zoom in on the area around Redmond, and I can just really easily draw a square here to populate a grid and hit fetch. And what's happening is this is a Silverlight application which is communicating with an Azure service. That service is looking over a large number of large data sets, and it's choosing the best data to answer the query. It's then doing a whole bunch of complex mathematical calculations and sending the result back to our application running in the browser. The answer of that query is now being visualized on top of Bing Maps via dynamic data display, which is another prototype tool that comes from our group. You can see that interactivity. If we hover the mouse over here, and we can see, for instance, that the average temperature in this place is about 2.8 degrees. We can download data. So we just hit download, we get a choice of formats, and we can see all the information that we would need from that query. It's got different times as well, so we can do a query for a fraction of the year or even a fraction of the day. And then we have the air temperature data itself. We have the provenance, so the data source that was used to supply this information, and we even have an estimate of uncertainty. That uncertainty is something that the experts find really hard to assign to data. That was a research project in its own right, and yet that's always supplied every time with a Fetch Climate query. Now we can, for the browser version, we can run multiple copies of Fetch Climate at once. And so I'm going to show you a couple of examples of fetches that I did earlier. So here's one of wind speed over the eastern US. And that's the kind of thing that you might want to look at if you're an energy company or the government planning wind farms. And in this fetch, I put a string of locations across Africa. And for each of those locations, I've extracted 60 years worth of rainfall data. And we can just hover over one of those points and see what's happening to rainfall. And unfortunately, this looks pretty worrying because it looks like there's been a steady decline in rainfall over the past 60 years. It's the kind of thing we've probably all seen in the headlines recently, African droughts and so on. So thanks to Fetch Climate, anyone can get that kind of information really easily. It's live, it's ready, go and find it, have a go, and please tell us what you think.
So again, Fetch Climate is really a great example of how now with our ability to process big data, we can make information available to everyone. If you want to use Fetch Climate, go out to Microsoft search engine, Bing, type in Fetch Climate, and you can get to this website and do your own analysis of your own area. See how the precipitation has changed over the last 100 years. See how the climate's changed, and understand what's going on. Now, another area of very rapid change right now in the field of computer science is in the way we think of computers interacting with us and with the rest of the world. Increasingly, we are giving our computers the same senses that we have. They can hear, they can see. If you use Microsoft Kinect on an Xbox, you're using a real-time 3D computer vision system. They know where they are. They have a GPS. They have a sense of movement, accelerometers. They have a sense of touch. You can play with your display. So we're giving computers the same kinds of access that we do. And it's changing the relationship between what historically was the virtual world of the computer and the real world that we live in. And it's giving us new ways of interacting with our computers, often referred to as natural user interfaces. But it's also giving computers new ways of doing things. So, for example, if you come to our research lab in Redmond, we have a computer vision and machine learning system that monitors people walking up to our elevators. As you walk up to the elevator, it can figure out that you're going to take the elevator, and it brings the elevator down for you and opens the door for you, so that by the time you get to the elevator, the door is open and ready for you. It's just like magic. It's very funny. You get used to a system like that very, very easily. A few days ago, before I came on this trip, the system was turned off, and I saw somebody walk up to the elevator, and they just stood there, and they didn't even think about pushing the button because they hadn't pushed the button in a long time. I mean, just like Star Trek, the doors just open when you need them to open. So that's the way the world's changing. I want to show you another video that talks a little bit about the new kinds of capabilities that we're giving to our computers to be able to understand us and monitor what we're doing.
Digits is a wrist-worn 3D hand tracker for gestural interactions on the move. The wrist-worn sensor allows the full 3D pose of the user's hand to be recovered in real time, while removing the need for wearing a data glove that covers the entire hand. The recovered hand pose can easily be used to recognize diverse gestures, even while on the move. Our system can be used in a variety of scenarios, including 3D gaming and augmented reality, where both discrete or continuous hand gestures can be used to control input. As the device is wrist-worn, no line of sight to an external sensor placed in the environment is required. The user can perform subtle gestures while resting their hands on their leg or table. Digits is built using only off-the-shelf hardware. The main components are a wrist-worn infrared camera, infrared laser line generator, additional diffuse infrared illumination, and an inertial measurement unit. One interesting interaction possibility Digits enables is 3D spatial interaction around a mobile device that is seemingly interweaved with traditional touch interaction. Here the user starts semantic zooming using an in-air pinch gesture and continuously controls the zoom factor with the remaining fingers. Another gesture is used for panning the interface or manipulating an object once it has been selected through touch. Another interesting design space for Digits is eyes-free interactions, where no visual feedback is required to control a mobile device. In this example, the user controls functions of a mobile device while the device is left in the pocket. Here, the user turns on the radio, switches channels by mimicking the turning of a dial, changes the volume by moving an invisible slider up and down, and finally answers a call by doing a thumb-up gesture. Digits can also be used for fine-grained 3D interactions, for example, as a wearable gaming controller. In this example, the user mimics a gun with their fingers to shoot targets, and navigates within the virtual environment by performing a grabbing motion and moving the arm, and also selecting objects using hand gestures. We have presented Digits, a wrist-worn sensor that recovers the full 3D pose of the user's hand in real time, while removing the need to cover the entire hand of the user. Thank you.
So again, I think what's really exciting now is to see all the new applications and the new ways you can think about using computers now that they can see us, they can hear us, they can sense where they are, and they know a lot about what we are and what we're trying to do. Now, another area that Microsoft Research works in isn't just, so in some sense, I said before, our goal is to move the state-of-the-art forward, and we're trying to make sure that the field of computer science stays vibrant, stays active, constantly generating new technologies. But Microsoft itself will never do all the work that needs to be done in the field. And so we want to work with academics, and from the beginning of Microsoft Research, we've always had a vibrant program of working and collaborating with the academic community. Microsoft Research runs the largest PhD internship program in the world. Over 1,000 PhD interns will work at one of Microsoft Research labs at some time, over the course of a year. To put that in perspective, I think that means we have more PhD student hours than almost any university in the world working with our labs. I think that then makes us the largest academic institution as well as the biggest publisher of basic research. But we also support basic research at universities. We fund basic research, we support faculty, we support students. So those have always been a key component. We also believe strongly in education and in finding ways of making education better and more effective, because really that's the way we're going to get the next generation of scientists, the next generation of mathematicians and engineers. I'm going to show you a video of some work that we're doing trying to find ways of making online education better and more effective. And this is some work that's being done in Microsoft Research India.
I'm going to show you a quick demo of an exciting new project we're working on at Microsoft Research India called VidWiki. VidWiki is an online platform to leverage crowdsourcing to annotate videos for legibility and clarity, as well as translating on-screen text. By adding layers to a video, users can improve, edit, or translate videos without having to create their own videos, releasing the burden on authors to update content or make videos in multiple languages. As an example, Here's a Khan Academy video playing on the platform with annotations appearing over the handwritten text, which is much easier to read. If I toggle the annotations off and then on again, you can see the change in quality. Using auto-translation tools like Bing Translator, supported by crowdsourcing to tweak translations, you can view this same video in other languages. As an example, here's the same video playing with Hindi annotations. The real power of the platform is the ability for members of the crowd to create their own annotations. Here is a video that has not been fully annotated, so I'll help out by creating an annotation. In the edit mode, there's a list of annotations here on the left, along with timing information. There's a list of tools at the top, along with some annotation properties on the right. So let's add an annotation. Here I'll use the text box tool to add some text. I'll first go to the time in the video that I want to add the annotation. Then, I'll draw the text box on the panel and type in the content I want to see. Using the properties, I can change the text color and size to match the on-screen palette. Finally, I'll move the annotation into place. Now, if I play the video, my annotation comes up over the handwritten text. I have several other tools I can use, such as shapes to emphasize parts of the frame. I can also add equations written in LaTeX and render them on the screen. Adding such equations is especially useful in science or math lectures, where symbols and subscripts can be hard to read in handwriting. To add new content, I can draw in an image using its URL on the screen. Here I'll add a graph of the historical exchange rates between dollar and won. And then I can use the free draw tool to highlight certain parts of the graph. Once I'm happy with my additions, I'll publish so others can benefit from my annotations, and I'll indicate how complete I've made the video. So that's been a quick overview of VidWiki, our project at Microsoft Research India to leverage viewers of online videos to improve their quality and make them more accessible across languages. Thanks for watching.
So in my job at Microsoft, in the work that I do at Microsoft Research, there really are times when I get to feel like a magician or a sorcerer. I can do things that really change people and amaze them. I was in China in October, giving a speech much like this one to a group of students, about 2,000 students at Tianjin University. And there I was able to demonstrate a system where, as I was speaking, my words were being translated and spoken in my own voice in Chinese. Things like that, experiences like that, are really why we do basic research. We're trying to change the world. We're trying to make the world a better place. And I think computer scientists and researchers have an opportunity to do that is really unique, whether it's in creating new ways of thinking about personalized medicine, personalized education, or in changing the way humans interact and solving some of the problems that we have in communicating with each other. I want to thank you very much for listening.